Okay, this is extension for 14.4, repeating decimals. Now, you have already written terminating decimals as fractions. For instance, 0.7 is 7/10. But because repeating decimals are rational numbers, they can also be written as fractions. So we have to be able to write repeating decimals as fractions. So here's the key idea. Here's how you do it, and I'm going to read that, and then we're going to try it a few times because it's a little confusing until you do it a few times. It says, let a variable x equal the repeating decimal, and they're just going to use d for any repeating decimal right now. So you'll write the equation x equals d, where x equals whatever and we'll put the repeating decimal in over here. For instance, 0.77777777. Multiply each side of the equation by 10, n, to form a new equation where n is the number of repeating digits. So for instance, in the one where I said 0.77777777, only the 7 is repeating. So one digit is repeating. We would only multiply each side of the equation by 10. Subtract the original equation from the new equation and solve for x. So actually that subtract the original equation from the new equation is a huge thing that you will do a lot of next year in math, but this is where you get your first taste of it. Yay! So write 0.4 repeating as a fraction in simplest form, of course, in simplest form. So example 1, there is 0.4 repeating. So we're going to write an equation, and our equation will be x equals 0.4 repeating. Now we can multiply both sides of this equation by 10, because as long as we do the same thing to both sides of the equation, it'll stay equivalent. If I multiply both sides by 10, this becomes 10x, because 10 times x is 10x. And if I multiply this by 10, it's just going to move the decimal one spot to the right, which will make this 4.4 repeating, because there's still an infinite number of 4s over here, same thing over here. So we just moved the decimal one spot, which brought that 1 4 out in front of the decimal. Well, now what we have to do is we subtract this first equation from the second one. Now, remember, we can only subtract the same thing from both sides to keep everything equal. But right here, this says these are the same thing. X equals 0.4 repeating. So if I subtract x from here, and I subtract 0.4 repeating from here, since these are equivalent, it says so right here, since these are equivalent, I can subtract them from each side and everything stays the same. Everything stays equivalent. 10x minus x is 9x. And 4.4 repeating minus 0.4 repeating, this part and this part will cancel each other out. Even though there are an infinite number of 4s here, there are an infinite number of 4s here, and when we subtract them, they all go away, leaving us with just 4. Well, now, of course, I can divide both sides by 9, and I get x equals 4/9, which is already simplified. So you can see we started with our repeating decimal, and we ended with our fraction. X equals 0.4 repeating, x equals 4/9. So 0.4 repeating is the same as 4/9. And they got the right answer. Good for them. I knew they could do it. Now, there are a couple for us to practice down here, which for some reason doesn't say on your own, but we're going to do them. Here we go. The first one is I'm going to just put x equals 0.1 repeating, because remember the first step was to set x equal to our repeating decimal. I multiply both sides of this by 10, which will give me 10x equals 1.1 repeating, moving the decimal one spot over. Now I subtract this first equation from the second, so I'll subtract x from over here, and I'll subtract 0.1 repeating from here. This leaving me with 9x, and this leaving me with just 1. I do a division, and I get x equals 1 over 9. 0.1 repeating is the same as 1 over 9. On our example, if you'll remember, 0.4 repeating was the same as 4 over 9. See if we can find a pattern here. Moving on to number 2. Negative 0.5 repeating. Oops, I was supposed to set that equal to x. I'll set it equal to x over here. X equals negative 0.5 repeating. I multiply both of those by 10, which will give me 10x equals negative 5.5 repeating. I subtract the first equation from the second, which will give me, I subtract x from here. And now I'm going to subtract a negative. Remember, minus a negative is the same as adding 0.5 repeating on this side. I simplify here, and that gives me 9x. Negative 5.5 repeating plus 0.5 repeating. These will cancel out. A negative and a positive. Different signs subtract. And I'll be left with just negative 5. Divide both sides by 9. And I get x equals negative 5 over 9. I started with negative 5 repeating, negative 0.5 repeating, and I end with x equals negative 5/9. Number 3. X equals negative 1.2 repeating. Multiply both sides by 10, I get 10x because there are two digits here, but only one of them is repeating. Only the 2 is repeating. So I only multiply by 10. And now when I multiply this side by 10, I do move that decimal one spot over still, so it'll give me negative 12.2 repeating. Just moving that decimal one spot to the right. Now I'm going to subtract this first equation from the second. Minus x over here. Minus a negative, again, this is going to be plus 1.2 repeating. This will give me 9x over here. And on this side, I'll be left with 11. This will cancel out. Negative 12 plus 1 is, negative 11. Now I divide both sides by 9. And I'll be left with x equals negative 1 2/9. I started with negative 1.2 repeating, and I ended with negative 1 2/9. Here's the next one, 5.8 with the 8 repeating. Without doing that problem, what would you anticipate the answer to be? I bet you are right, but we'll try anyway. X equals 5.8 repeating. 10x equals 58.8 repeating. Subtract x, subtract 5.8 repeating. 9x equals 53. Divide both sides by 9. And x equals, well, 9 goes into 53, 4, 5, 6, 5 times, which would be 45, leaving me with 8 left over. 5 8/9. Did you think that would be 5 8/9? I bet you did. This is a little different because both numbers are behind the decimal here, but still only one is repeating. So let's try this. X equals negative 0.23, where just the 3 is repeating. Multiplying both sides by 10 would give us 10x equals negative 2.3 repeating. Subtract this equation from this one, minus x minus 0.23. Oh, plus, because I'm subtracting a negative. So I'll have 9x over here. And now this isn't really that tricky, but it's a tiny bit tricky. There's nothing here to subtract from. So what do? Do I put a 0 there? No, because it's a 3 repeating. So I put another 3 there. I have an infinite number of 3's back here. So now that repeating bar, I'm just going to move over there. That 3 is still repeating. And now these 3's that are repeating will cancel each other out. I'm left with a 3 minus 2 is 1 decimal negative 2. Divide by 9, divide by 9, and I get x equals, what in the world would this be? Well, I know it's going to be negative because there's one of each here. That's a decimal, not a multiplication. I'm going to multiply the top and the bottom by 10 to move this decimal out of there. So when I do that, I'll be left with negative 21 over 90. Just multiplying top and bottom by 10, of course. Now I know 3 goes into both of those. So that would be negative 7 over 30. Negative 7 over 30. Well, this one didn't work out quite as well as those with the where it was always over 9, but it was still not a hard problem to do. Negative 7/30. Negative 7/30. The last thing we're going to look at is sometimes there are more than one digit repeating. For instance, right here. We're going to set it equal. X equals 1.25, and now I have 2 digits repeating. I do not multiply by 10 now. 10 was when I had 1 digit repeating. Now that I have 2 digits repeating, I multiply by 100. So it'll be 100x equals, move that decimal 2 places this time, 125.25 with the 25 repeating still. Subtract this original equation from this one. So still subtracting x from here and subtracting 1.25 repeating from that side. 99x here. And over here, of course, this cancels out, and 5 minus 1 is 4, 124. Divide by 99, divide by 99, and I get x equals 1 25/99. And we can see a similar pattern here. When 2 digits are repeating, it's over 99. Instead of 1 digit repeating over 9, 2 digits repeat, it goes over 99. So 1.25 repeating is 1 25 over 99. Well, they do give us 4 problems to do down here. 3 of these are going to be, 2 of them are going to be quite simple. Number 9, we'll do 9 and 10 first. Number 9, just using our pattern that we would see up here, is going, just the 0.27 repeating is going to be 27 over 99. And here, number 10 is going to be negative 4 and 50 over 99, because there's 2 digits repeating, it's over 99. Now, doesn't work quite so well here because it's the second digit behind the decimal repeating, but when we can find a pattern like that, we should probably use it when it's applicable. Now we have to work these out. So, let's move this up here. Not so far. There we go. Number 7. 1 digit repeating. Oh, that's funny. I put the 7 on the wrong side. X equals negative 0.43 with the 3 repeating. one digit repeating, so I'm multiplying by 10. I get 10x equals, that moves that decimal only one spot, so negative 4.3 repeating. Subtract the first equation from the second. I'm subtracting a negative, which is the same as adding. 0.43 repeating. This side, 9x. This side, I'm going to have to, I don't even know if you call it annexing a 3 here, but I know I'm going to put another 3 because it's the 3 repeating, where these and forever, those cancel each other out. 3 minus 4, so I do have to borrow here, and I get negative 3.9. Divide both sides by 9, and I get x equals, and now, again, I have to move that decimal out of there, so I multiply top and bottom by 10 to get negative 39 over 90. I can simplify by 3 to get negative 13 over 30. Negative 13 over 30. And the last one, number 8, not really the last one, but we already did 9 and 10 because they were pretty easy. Number 8, x equals 2.06, only with the 6 repeating, only one digit repeating. So it'll be 10x equals, multiply by 10, move the decimal once, 20.6 repeating. Subtract the first equation. Reveal another 6 here so I can do my subtraction. 9x equals, those cancel, 618. Divide by 9. And x equals, I don't like that decimal up here, so we will multiply by 10 on top and bottom. 186 over 90. And then what goes into both? 6 goes into both of those. 6 goes into 186 31 times. And 6 goes into 90 15 times. So 31 over 15, which is 2 1/15. Excellent.